So right now, we delve right into the definition of groups. The question arises, what is a group? A group, a group is a set of objects. So let's just denote it by A, B, C, etc. Along with a binary operation that follows the following axioms or the conditions. So we have four conditions. Number one, let's denote it by G1. G just stands for group. So the first condition is, oh, by the way, so we denote this group by some symbol G. So the first condition says if we have two elements of this set and we join them by means of this binary operation, let's denote it by a star. So A star B denotes two elements of G acted upon this binary operation. This new product will be a member of the same set. So that's our number one condition. Our second condition is that this binary operation is associative. So that means if we have A star, B star, C, so we take the binary operations of these two members first, and then because the resultant product is a member of the set G, we can then create its binary operation with A, and that is the same as first creating the product A star B and then star C. So the first axiom, we call it the closure axiom, and the second one, we call it associativity of the binary operation. Our third axiom involves the postulation of an identity element. So that means in all groups we have an identity element, let's just denote it by E, which when combined with some other member of this set G will be the same as creating the product in the reverse order. So this reversal of order is only applicable for this particular element, not for elements in general. And we'll talk about that within a bit. So E star A is the same as A star E, and this altogether simply means the element A. So this is like the behavior of the number 1 under multiplication. And so keeping up with the analogy, we will call this element E as the identity element of this set or of this group, and we call this postulate the existence of identity. Last but not the least, we have the fourth axiom, which postulates for each member of the set or the group its inverse. So for all members A of this set, there exists another member, let's call it B, such that this A, when combined with this element B, is the same as combining the elements in the reverse order, B star A, and this altogether will give me the identity. By the way, this element will be unique. So for each member A, there will exist a unique member B of this set which follows this criteria. So conventionally, we call this other element as the inverse of A. So this postulates the existence of inverse elements for each member of the group. And by convention, we do not write different symbols for inverses. What we do is that for a member A, we simply write A inverse. So instead of B, we write the inverse as A inverse, which is also a member of the group. And this will have the property that A star A inverse is the same as A inverse star A, and this will give us identity. So there we have it. This is the definition of the group. So a group is a set of objects along with a binary operation that follows these four axioms, namely the closure axiom, the associativity of the binary operation, the existence of identity elements, and for each member of the group, the existence of an inverse element. And this will give us the definition of group. I'd now like to point out a bit of technicality. So I write them as the side notes. So note number 1, notice that not for all members we have A star B as the same as B star A. So this is not true in general. So in general, these two sides are not the same. But for some group, they can be the same. So for some group, this relationship A star B is indeed the same as B star A. So this relationship holds. And B doesn't have to be an inverse of A. It just can be any member of the group. And for some group, this relationship holds. Those groups are called commutative groups, or abelian groups. So that's number 1 trivia. And the second trivia is that for a lot of cases, we will not write the star explicitly. So from now on, this star will be omitted, and we'll presume there is a binary operation there. By the way, there is another observation, and that is this star does not mean multiplication. In some cases it might be, in some other cases it might be addition, it might be some sort of modular multiplication, and it can be anything. It's any binary operation that is suitable with a set and satisfies the 4 axioms or 4 criteria will then be qualified as group. In the next video, we'll be talking about a couple of important examples that will solidify our understanding of this definition, and then we'll move on to the classification of groups. See you on the next video.